Alright, in an Algebra 2 course, you might see this polynomial term, and you are shown its factorization, and students have to memorize these things. But where do they come from? Can we derive them? Can we demonstrate this to our students? Can we challenge our students to figure out where this derivation comes from? There is a geometric motivation behind this, and I want to look at that geometric model today and derive the factorization of this so that we can see where that comes from. So we're going to start with a diagram of a cube. So this cube is going to have side length A. And so the height is A, the depth is A, and the width is A. And then we're going to subtract a cube from it, say this corner. And so this cube that we subtract from it is going to be length B. So it has a length of B, width of B, height of B. And we're going to subtract this from it. So we're going to look at the geometry behind this. So we're going to essentially break this cube up into multiple prisms. Alright, we're breaking the cube into prisms based on this piece that we're taking out here. So in this front, I'm going to have this prism here. This is going to have a length of A minus B. It's going to have a height of A, and it's going to have a depth of B. So if you want the volume of this prism that I've just highlighted here, it's base times height times depth. So we have this first piece here is A minus B times AB. And adding that to the cube that we're subtracting out at the end here. We also have this prism that is above it. It has a width and depth of B, and then it has a height of A minus B. So this is B times A minus B for this prism that's directly above it. Behind what's going on here, we also have this bigger chunk of the cube, and it has a depth here of A minus B. It has a height of A, and it has a depth this way of A also. So this is A minus B times A squared, and from all of this we subtract this. So this accounts for the entire volume of the cube minus this little cube that we are taking out. So I have this plus this plus this minus this accounts for the cube with the cube removed. All of these added together is the entire volume of the cube. We have this plus this plus this plus this. All these prisms added together is the entire A cubed. So now if we want to have A cubed minus B cubed, we are going to subtract B cubed from each side, and so A cubed minus B cubed is going to be equal to whatever is left on this left-hand side. And then we have to do the algebra to simplify that and find out what factors that we actually have. All right, looking at the terms that we have here, I'm going to associate all of these together, And I'm going to factor out this common term of a minus b. And so I'm going to have a minus b times, and then I'm going to put this in a kind of standard look. So I'm going to put my a squared plus ab plus b squared here. And so I've just commuted the terms in here and factored out the a minus b. So now I have a minus b times a squared plus ab plus b squared is going to be equal to a cubed minus b cubed. And so I have this nice factored form here. So this is factors of this, and I arrived at this method not through algebra directly, but by using a geometric model to get a hold of the idea of what we're trying to do here and to create my terms and factor from that point. And so we arrive at our fact that some students might have to memorize. Maybe we've memorized it and not realized how this factorization occurs. And we have this nice geometric understanding. If you have these snap cubes, you can build a nice model of this in which you can snap apart the different prisms so that students can get an idea of how you're breaking this apart with a real 3D manipulative. The drawback that tends to happen in my experience with students looking at the model like this is they want to count each of these cubes and somehow incorporate it into here in a non-general way, and so they lose the generalization of the algebra in trying to count those cubes. It can make a nice specific example, but sometimes it causes an issue for students in which they don't get that generalization. Cheerful calculations.